In this recording, we're going to study vectors. Now, vectors are all around us, in fact. We're going to show you some examples in a moment. And they're also excellent applications of our triangle trig, our law of sines and law of cosines. Let's consider this example. You know that there's a jet stream that goes from our west coast to our east coast of our country. That brings our weather from the west to the east. I don't know if you know this, if you've ever had experience traveling cross country, but if you're flying in a plane from the west to the east, from California to New York, it doesn't take quite as long as if you're to fly from New York to California. And hopefully you can realize it's because you're fighting that jet stream if you're going from east to west. You're having to go against the wind, so it takes a little bit longer. In this direction, you're going with the jet stream, so the effect of the airplane's engine combined with the effect of the wind makes the trip faster. Grab your companion sheet and let's fill in some definitions. First off, a vector. Well, a vector is simply a quantity used to measure forces. And if you remember from Despicable Me, if you saw that movie, a vector has two components: direction and magnitude. Obviously, direction is what it says. Magnitude is like the scalar, or the amount, how strong it is, basically. Let's think of some examples of vectors. Well, certainly anything that has a direction and a magnitude, like wind is a perfect example, is an example of a vector. But there are others. Okay, examples of vectors or forces: wind, any engine or motor. Gravity certainly has the same direction all the time. A magnet is an excellent example. Has a direction as well as a magnitude. You could be an example of a force, right? You push up a weight, or you push on a chair with wheels on it. That chair goes in a particular direction and at a particular rate depending on how strong your force was that you pressed it at. So you're an example of a force. Let's look at how we're going to calculate these forces. Alright, let's turn to one of my favorite gizmos here, the adding vectors gizmo. So vectors are represented with arrows. And you can see the blue arrow, the blue vector, is longer than the green one, and it points in different direction. So you can imagine this is like the wind, the green arrow. This is the blue arrow, the strength of the engine of the airplane. So where's the airplane going to go? Hopefully you can realize it's going to go somewhat in the middle here, right? It's being pulled by both not in opposite directions, generally to the right, but stronger from the blue, so it's going to be closer to the blue. Okay? So hopefully you expected something like that. The purple is the resultant, we call it. It's where the plane would actually go. If its engine were pulling it in this direction and the wind were pulling it in this direction, it was going to go in this direction but stronger than either of them. The question is, exactly where do we put it? And what we do is we make a parallelogram of forces. So basically, if you took the B vector and put it right up on top here, parallel and the same length, and took the A vector, put it on the right here, wherever those vectors intersect, the diagonal is the resultant force. That's what we call this C. That's where the thing ends up going. And you can see what happens is we produce two equal triangles, two congruent triangles that we can operate on using our law of sines, law of cosines. Okay, so let's do some of those calculations. On your companion sheet, in your first example, it talks about a 25-pound force and a 40-pound force acting on a body. Basically, that means pulling on this body, this object. You can think of it like a swivel chair on wheels. They're getting pulled in two different directions at an angle of 60 degrees and with different amounts of force. And our question is, what is the magnitude of the resultant? How strong is the actual force of the resultant, where it actually goes? So we're going to make a picture. Every time we're going to make a triangle picture. In fact, we're going to make a parallelogram picture that has triangles in it. So, like on your paper, you just sketch a 40-pound force at an angle of 60 degrees with a 25-pound force. Doesn't have to be a perfect 60 degrees, just get it going less than 90, and make the 25-pound force smaller than the 40-pound force. Next, let's draw in the parallelogram. Okay, obviously the side across from the 40 is equal to the 40, side across from the 25 is equal to the 25, and at roughly the same angle. Then we can draw in the resultant, which goes on the diagonal. That's where the thing actually goes. That chair that you're pulling actually ends up going. The x represents what we're trying to find. We're trying to find the length of this diagonal. That's what it means, the magnitude of the resultant. Okay? And to do so, we're going to have to find small triangles. Hopefully you can see that there's a red triangle in here that we know enough information about to solve. We have to use the fact that in a parallelogram, consecutive angles add up to 180. They're supplementary. So because this is a 60-degree angle here, this must be a 120-degree angle there. Now using that fact, we now in this red triangle have enough information to solve for x. I want you to think about what law you would use. Play the recording when you're ready to proceed. Okay, so hopefully you would have thought that we'd use the law of cosines because we have a side, angle, side, and we're looking for another side. So set up your law of cosines, sub in all the information, and play the recording when you've got your answer, rounded to the nearest tenth of a pound. Okay, so hopefully you subbed in all the information, lining up your angle 120 degrees with the unknown side. This is just an easy calculator problem. Once you've got it all set up, don't make it harder than it is. Put that all into the calculator. Get your value, 56.8 pounds. Make sure you have your unit. Make sure you rounded it appropriately. And then finally look at it and say, is that likely? Well, yeah, it seems reasonable. 56.8 is bigger than 40 and 25 because it's across from the largest side. But it can't be more than the sum of 25 and 40, which is 65, because one side can't be larger than the sum of the other two sides in a triangle. So it seems like a good answer. Let's check out question 2. Okay, question 2 asks about two forces, again, except at an angle that is unknown. They act at an acute angle to each other. However, we know that the angle between the resultant and the 450-pound force is 42 degrees. This is a really good question. Let's sketch out what we know. We have the two forces. I tend to draw one of the forces horizontally. It's just easier for me. I make an acute angle here between the two forces, but the angle between the two forces isn't 42. The angle between the 450-pound force and the resultant is 42 degrees. So let's back up. First thing you're going to do is draw your two forces, 835 and 450. Then you're going to sketch in your parallelogram so that you can draw your resultant. Lastly, you're going to draw in your 42 degrees right here. Alright, let's label anything else we know on this drawing. Biggest mistake students will make is they'll want to put in this angle up here on the top, and you just can't do it. You do not know that value, so do not label it. You cannot figure that out right now. You're going to need to do some law of sines, law of cosines to figure that out. Okay? Let's concentrate on this red triangle right here. We want to find the angle between the two forces. In other words, this whole acute angle here. And so if we could figure out what theta is, we just add it to 42 and we've got our answer, right? Notice that in a parallelogram, alternate interior angles are congruent. You remember that from geometry? So if I could figure out this theta, I'll know what this theta is. We can get our answer easily. So look at what you've got here in this red triangle. Think about what law you could use to solve for theta, then play the recording. Hopefully you realize that law of sines is a relevant law because we have side, side, angle, looking for this angle. So you set up your law of sines. I'd like you to play the recording when you've got theta solved for. Okay, we'll multiply both sides by the LCD, divide out. Need to divide both sides by 835. I need to do the inverse sine to solve for theta. And when I do, I get 21.1 degrees. That seems like a reasonable answer because it's across from the 450, which is less than the 835. Again, I'm always checking for reasonableness. We'll catch silly mistakes that way. That's not the answer to the question, though. The answer to the question is find the angle between the two original forces. So we have to add 42 plus 21.1 degrees. 63.1 degrees is the answer. Again, always go back to the original question. Make sure you're answering that question. Last example I'd like to consider is number 3. Okay, it says, for the body in number 2, find the magnitude of the resultant force. Okay, so now we know this is a 21.1, and I'm interested in the resultant force, which would be right here in the middle. Okay, so that's the x. We also happen to know that this angle up in this top left corner is supplementary to the 63.1 that you computed in the previous question. Therefore, check out what we've got in the red triangle. Okay, I've got side, angle, side, and I'm looking for side. Or I could use law of sines and work it out. So I can use law of cosines, I can use law of sines. In this case, I'm just going to use a nice law of cosines. Angle across from the side I'm interested in. Everything on the right side is numbers. Punch those into your calculator. You've got 1,113.4 pounds. Seems like a reasonable answer. It's much bigger than the other sides because it's across from a much bigger angle. So hopefully from this recording you've got a decent sense of what a vector is, how you set up your parallelogram of forces, and how you use your law of sines and law of cosines to solve for unknown sides and angles. So now it's your turn. I'm going to leave you with this question to try to figure out, and you can enter the question in your Edmodo quiz. Okay, so we've got two forces acting on a body where you know all three, you know the resultant and the two forces. And I want to find the angle between the resultant force and the smaller force. So make your sketch, label everything you know, use your laws in one of the triangles to solve for that angle, and then bring your answer to class and enter your answer into Edmodo. Thanks for watching.